Hi guys! Did you ever wonder how you could improve or modify a certain STL model before printing? And for the guys that have 3D scanners, you most certainly have scanned models that need some type of repair or tweaks, am I right? If the answer is yes, then you will not want to miss this video. So stay tuned guys! Hi guys, welcome back. My name is Rui and this is the Rui Raptor YouTube channel. If you want to help us out, you can by giving this video a like and subscribe to the channel. You can also help by joining our Patreon page or by clicking on any of the affiliate links posted below in the video description. So, we have been seeing several manufacturers releasing better and more affordable 3D scanners to the market. While a professional 3D scanner can cost thousands of dollars, the consumer scanners cost hundreds and still get pretty decent results. Although the 3D scanner technology is getting better, this does not mean that the 3D scanning process is a one-click process. Once the scan is done, we still need to process the scanning data and fix some errors or imperfections on the mesh. Normally, if the scanner has a good software, it can resolve most of these steps more or less automatically. However, for the imperfections, we need to fix them ourselves. There are several computer programs that can be used, but for our tutorial, we will use one of the best, not only for what it can do, but also because it's free to use. The software we are talking about is Meshmixer and can be downloaded for free from Autodesk. To work with it, you can use a mouse obviously with a screw wheel, but we often use this pen tablet as well. It's not required, but for certain tasks like drawing with the sculpt tools, it will be different. This one is not very expensive and has a few buttons at the side that we can use as short keys. For the 3D scanner, we will use the RevoPoint Inspire. The goal of this tutorial is to be practical and tip-orientated, so we will try to avoid the boring parts. Having said that, we will not focus on all the details of neither the scanner software or Meshmixer, but instead, we will try to cover all the tools we normally use to complete the task. Okay, so let's start with the scanning itself. The way you work with the scanner will have an impact of how good or bad the scan result will be. Always check the gain before starting the scan and, if possible, enable the Hide Surfaces feature. Also, try not to scan the same area many times. If you scan the same area too many times, the level of detail of that area might be reduced. If your software allows this, pause the scan and change the orientation of the model to cover the remaining areas. If your model has dark areas, the scanner might not be able to capture it as well. There are special sprays that you can use in these cases. The spray will add a very thin coat on the model so the scanner can capture it better. For this one, you need to clean the model once the scanning is complete. But for this one, you don't need to clean the model since the coat will disappear by itself after some time. It's also possible to make your own coat with household items, such as baby powder or dry shampoo. For models with not enough features, the scanner will have a hard time to scan it. For these, you need to add markers. The markers can be special ones like these, or any other sticker or object. The important thing is that the scanner can see it and track it. Once you covered all the areas of the model, we need to process the scan data and mesh. This software can do this manually or automatically. At the end, we just need to check a few things. First, if we have some extra stuff. If they are not attached to the model, we can run the isolation button and delete them. If they are attached, we need to remove them manually. We can do this here or in Meshmixer, but we often do it here. Once the area to be removed is marked, we can delete it. One other thing we need to check is if the mesh is closed or open. There might be areas that the scanner didn't cover, so we need to close the holes. The scanner software can also detect this. If it's located on a flat area, you might want to choose plane. If it's not located on a flat area, choose curve instead. Okay, the model still needs a few tweaks, but from now on we will use Meshmixer instead. So let's export the mesh as STL and done. Next, we open Meshmixer and import the STL file. Now, if it's your first time with Meshmixer, there are a few things you need to know from the start. One of them is how to move. First, check if the free rotation option is enabled. If you press the right mouse button and move the mouse around, it will move like this. But if you press the mouse wheel while moving the mouse, it will move like this. Rotating the mouse wheel will move in or out. At the left, you have a few buttons. The Meshmixer at the top is a section where you can add models. This section might not be too important, but it will be, as we'll show later on. Next is the Select tool. We use this when we want to select specific areas and do certain tasks. Then there's the Scope section. There are a few ones, but the ones we'll be using the most are the Draw to, Flatten, Inflate, Bubble Smooth, and Shrink Smooth. If you press just on the left mouse button, the tool will react one way. But if you keep the control key from your keyboard while you press the mouse button, the tool will react the opposite way. Also, the longer you press, the more it will react on the model. For each tool, you have the adjustments, strength and size. Strength defines how much the tool will affect the area, while size sets how big the affected area will be. Then there's the fall off, which allows you to select different shapes for each tool. Next is Stamp, but we will not cover this on this video. The Edit with some options, and also the Analysis with a few more options. We will cover some of these as we go, so stay with us. Okay, let's start with the orientation and fixing the bottom of the model. This is important because the scan model is almost never leveled on the X, Y, and Z axis. And as this example shows, the bottom is not flat when it should be. Meshmixer has tools to do this, but we think that the way we do this is faster and easier. Our trick is to open the model on the slicer, which in our case is Bamboo Studio or Orca Slicer. As you can see, the default orientation of the model is not leveled on the bed. So, we start by selecting the tool to place the bottom side on the bed. You might need to rotate the model a little bit to make it leveled. Then use the Cut tool and slice the bottom part that you don't want and keep what matters. That's it. The model is now leveled and with the bottom side closed and flat. We then save the STL and import it back on Meshmixer. Saving the STL file from this slicer will also save the new orientation. Now that we have our model with the correct orientation, we can now check all the things we can do to tweak it and make it better for 3D printing. The most obvious are the scanning errors. It's always a good practice to run the inspector. The inspector tool is used to repair a few common mesh problems. It will first show us how many and where the major problems are located. In this case, it didn't detect any major problem, so let's show you guys a different example. This other model has a couple of openings on the mesh, so running the inspector will detect exactly that. You can click on each sphere to fix individual issues, or click on Repair All here at the left. There are other issues that are not detected by the inspector and need to be fixed before printing. At the back of the shell, we have the marker, which we need to remove obviously. There are several ways to do this. One of them is with the draw tool. Adjust the size here and adjust the strength. It's okay not to be sure how much thickness to use. Just use the tool on the area, and if you don't like the result, just undo it and it will go back. Again, if we keep the Control key pressed, the tool will do the opposite. So, normally, this tool would increase the area here, but because I'm with the Control key pressed, it will reduce instead. For this particular case, the flatten tool is a better option than the draw tool. Since this tool calculates the average to flatten the area, we need to increase the size quite a bit and pass several times. There are several options and different techniques for each thing we are doing here. The guys that have more experience with Meshmixer will certainly have different ways to do a particular task. Our goal here is to show you how to do the first steps and start using this tool. For the rest of the learning path, you can find many great tutorials online. After some passes with the flatten tool, we can see the differences. It's possible to smooth areas more easily with the smooth option. For this, you use the select tool and select the area you want to smooth and a bit of the surrounding area. Then go to Smooth and adjust the slider for the best result. This alone improved a lot, but we still need to do some manual corrections with the Flatten tool. One thing everybody likes is detail. Some scanner models can provide more detail while others cannot. For this one, we can see that the details are here but a bit shy. So let's go ahead and use the drawing tool and carefully dig these lines. Play with the strength value to find the best result. With just this small adjustment, look at the difference. These new lines are already improving the detail and the overall appearance of the model. Okay, you get the idea. Now, we need to do this where needed. Remember this strength adjustment? It will be used a lot for this next step. We will now try to improve the appearance of the cracks on the eggshell. For this initial area, we will want more depth, so we will increase the strength. This will remove more amount for each button press. There are other tools you can use for this, so don't be afraid to test and explore all the tools in here. If you don't like the result, just undo and try again. And for the other end, we will want much less strength, so we get that appearance of the shell cracked fade. Be careful with the amount of detail in certain areas. Remember that if you are doing this for 3D printing, you need to avoid unnecessary overhangs. So keep this step to a minimum. If you have doubts about the overhang amount, there's an option to check this under Analysis. Make sure you set the same value for the angle that you have on your slicer and you get the result. To smooth the edges of the eggshell, we can use the Bubble Smooth tool. Okay, not perfect, but we are happy with it. Let's print it and see how it turns out. When exporting the STL file on Meshmixer, always make sure you select this STL format. If we place the before and after models side by side, we can clearly see a big change, especially in detail. And this is how it turned out. What do you guys think? Let us know in the comments section below. Scanning models with certain features like deep holes might not be captured correctly as well. This example is a small figure that holds a couple of incense sticks. The scanned version does not have these holes for the sticks, so we will need to create them. For this, we will use a couple of cylinders. Drag and drop one to our working area. On the transform box, set the size. On our case, we will want a couple of 3mm holes in diameter. The depth is not important, so we will set them as 3mm as well for now. Sometimes this happens where the shapes get out of your view. This happens because our model was not aligned, but it's okay. Just zoom out and you will find it. Now we move the cylinder to the position we want, using the arrows for each axis. These curvy lines are used for rotation. And now increase the length of the cylinder. You can use the small squares to increase the size or edit the values at the left. As we said, we don't care about the length, but one thing we don't want is for it to pass through the back. Now that we have the first cylinder in place and selected, we will make a copy of it using the duplicate button. We can toggle the view on each piece on the object browser like this. This is handy so we can easily select the second cylinder. And then we shift it to the side like this. The two cylinders will be used to create the holes on the model. So, on the object browser, we first select the model and then, with the Shift key pressed, we select one of the cylinders. Then, go to this menu at the corner and select Boolean. Remove this check and go for it. The result will be our model without the cylinder and the hole where the cylinder was before. Now we need to select the model again and the other cylinder and repeat the process. Done. Now we have the two holes for the incense sticks. If your model cannot be printed in one piece, like this one for example, you can cut it to ease the 3D printing process. For that, you can use the cut plane tool. The plane you see on the image will slice the model, so we need to change the orientation for what you need. Part of the model is transparent, which means that it's the part of the model that will be removed. You can invert this by clicking on the big blue arrow. Once that is done, you need to check the settings here at the left side. If you want to remove the second part, leave this setting as is. Unless you want to keep both, then change to this. And there you have it. You can fix the orientation of this new part if you want, and then export it. And with an extra effort, you can even create pins to attach the two pieces together, but this is a subject for a different video. If you plan on printing a model in vase mode, or if you have a resin printer, you will most certainly need to make the model hollow and also make some drain holes. One of the ways you can use is the hollow option in the edit section. The hollow options will appear on the left hand side and you can adjust them. Normally this tool takes some time to process, and that's why it does not render automatically when changing the settings. If you want to see the preview, you need to click here on Update Hollow. The offset distance setting will change how thick the model's wall should be. At this point, it's important for you to know your nozzle size and use that as reference for the wall calculation. For example, we have a 0.4mm nozzle, so each wall line will have the 0.4mm thickness. We're going to set the wall thickness to 1.2, which means we will have 3 walls of 0.4mm. The solid accuracy controls the accuracy of the new inner shell from the outer shell. If you want your inside wall to have most of the detail from the outer wall, then set this high. Then you have the mesh density, which is the number of triangles the inside wall will have. Again, if you want more detail, set high. If you are using a filament printer, you probably will not need draining holes. But if you have a resin or powder printer, then you will need them. The number of holes are set here. If you don't want to create draining holes, you don't need to change this. Just don't click on Generate Holes and they will not be made. If you are happy with the results, click on Accept to start the hollowing process. Once that is done, you will not see the changes, at least from this perspective, because the model is closed at the top and at the bottom. If you want to create an opening at the top, just use the plane cut and trim the top of the model. Remember that you have 1.2mm of thickness also at the top, so you need to adjust the plane below that. This view gives us a better understanding if we are below or above the top wall. Let's just flip this because we want to keep the bottom part of the model and not the top. And done. The model is hollow. Last but not least, the resulting file size. After working on your model, you might notice that Meshmixer exported your STL with a significant file size. Again, Meshmixer has tools to remesh and reduce the file size, but we have a much faster technique. Open the model on the slicer and simply save the STL file from there. The file is saved super fast and the file size will be much smaller and you will not notice any quality reduction. Simple as that. And that's it, you guys. We hope this video is a good help for you to start repairing your models for 3D printing. Thanks for watching. We will see you guys next time. Bye!